don't want to make these videos too long, so I think we'll probably finish on this question, not to have too much in one video. So find, for the following exercise, find the domain, range, 0, and intercepts. Okay, so we want the domain, range, 0, and the intercept. Let's start off with the intercept. Fx equals x over x squared minus 16. It might be good to write that as x over x plus 4 times x minus 4, and that's the difference of two squares. That's the name of the rule I'm using here to turn it into that. So let's start off with the intercept. So the intercept, that's simply f0, and that's perfectly fine to calculate. That's 0 over minus 16, which is 0. So that's the intercept. Interestingly, let's get the 0 now. So that means we want to solve fx equal to 0, which means x over x squared minus 16 equal to 0. Which basically just means x equals 0 times x squared minus 16. So x is equal to 0. So that's where the 0 is for this one. Coincidentally, also the same location. So I just want to be a bit more explicit here. The intercept is 0, 0, and the root, the 0, is also 0, 0. I wonder how the answer is given at the back, if it's a coordinate or just a single point. Just to be clear, y equals 0, x equals 0 is also what I'm saying. Okay. Now the range. No, the domain would be the easier one to do next, the domain. So if you examine this function here, it can take all values of x. There's only a problem when x is equal to minus 4, because you'll divide by 0 in that case, or 4. So therefore, the domain is basically all the real numbers from minus infinity to infinity, except for minus 4 and 4. That's what that symbol means. All numbers, real numbers from minus infinity to infinity, except for minus 4 to 4. You can also write it like this: all real numbers except for minus 4 to 4. Okay, and then lastly is the range. There's different ways to find the range. Personally, I like to do it like this. I start off with y equals x over x squared minus 16. And my technique, the way I like to do it, is you pretend that y is a constant and solve this equation. So that would be y times x squared minus 16 times y. Just cross multiplying here. Yx squared minus 16y equals x. So this looks like a quadratic. Y times x squared minus x minus 16y equals 0. So remember, pretending that y is a quadratic. And then what you do next is you ask yourself, when is this solvable? I'll need to make a little bit more space over here. So firstly, just note, is this solvable when y is 0? Yeah, that's okay. If y is 0, this does disappear, but you still have an x left here. So and this would disappear, this would be 0. So you end up getting x is 0, which is perfectly fine. But in general, when are quadratics solvable? When do they have solutions? And the answer is when their discriminant is greater than or equal to 0. In other words, when b squared minus 4ac is greater than or equal to 0. So that would be minus 1, that's the b squared, minus 4 times a, which is y, times c, which is minus 16y. That needs to be greater than or equal to 0. So let's see, that's 1 plus 32 y squared. That's greater than or equal to 0. Well, that's great, because this is always greater than or equal to 0. There's no value of y I could think of that wouldn't make this greater than or equal to 0. So to me, this looks like we can get every value. All y's are permitted, including 0. So all y values are allowed. So that means that the range is all real values. We prefer minus infinity to infinity. Let's just test that out. What I'm saying is, if you were to look at this function here, I can give you any y value you want. I can find an x to do that. So, for example, if you say you want y to be a particularly a large number, what I could do is make x be very close to 4. Because if x is very close to 4, then this would be extremely small, and you're dividing by an extremely small number, it'll make it extremely big. And you might say, okay, well, what about if I want a really big negative number? Well, I'll just make x close to minus 4. Again, this will be very small, but because the numerator is minus 4, it'll be a negative in total. So I can get a very large negative number. You might say, okay, well, now I want you to make x really close to 0. Well, or y really close to 0. Well, then I just make x close to 0, because 0 over a big number, be 0 as well. So I think it's possible to achieve any value of y. I can always find an x that can give me that. The only values of x I can't use here is 4 and minus 4, but that would make this run off to infinity, and that's never something you could ask for y anyways. So I think that's okay. Unfortunately, this answer is not going to be at the back because it's an even question, I think, but we'll check it before we finish. Yeah, it's not. It's not. Okay, let's leave it there for today.